Hey guys, today we will be working through two problems related to square roots. The first one says, calculate the square root of 2¼ Automatically, the first step you would want to take would be to turn this mixed fraction into an improper fraction. So 1/4 stays as 1/4, but we would have to express the number 2 using the same denominator of 4. So it would be 8/4. So put 4 on the bottom of the fraction, and on the numerator we have 8 plus 1, which is 9. Now, to solve the square root of 9/4, we have to know a few basic operations regarding exponents and roots. This is where the reviewing comes in, right? Always review before a test. Anyways, the rule that comes to use here is that the square root of 9/4 is equal to the square root of 9 divided by the square root of 4. Now, you might say, hey, the square root of 9 can be 3 and -3, and root 4 can be 2 and -2. But strictly speaking, here's where another rule kicks in. The square root of a positive number can only be positive, and it only appears as negative when there is a negative sign next to the root sign. Therefore, root 9 is 3 and root 4 is 2. So the answer would be 3/2. On to the second problem, a little more challenging. This time we are going to be tackling the estimation of square roots, in particular the square root of 234. First, we know that as a non-negative number increases, its square root increases too. Using this piece of knowledge, let's go ahead and make things easier by recognizing the square root of a perfect square closest to, but smaller than, 234. Well, the perfect square would be 225, and the square root of that would be 15. Let's go ahead and write that down. So we know that the square root of 234 should definitely be larger than 15, but how much larger? This is where the estimation comes in. For now, let's remove the square root symbols, which leaves us with 225 and 234. Now, let's plot these points onto a number line with a unit bar length of 1. We know that 234 is 9 more than 225, but I'm thinking that isn't enough because we need to apart the whole relationship here. So let's go ahead and find the perfect square immediately above 234, which turns out to be 256. At this point, what we can confidently say is that the ratio between the differences of 234 and 225 and 256 and 225 is 9:31. So it seems very reasonable now to put the square root symbols back onto the numbers and still maintain the same ratio. Well, previously we said that 256 is 31 more than 225. But now the square root of 256, which is 16, is only 1 more than the square root of 225. So now with the same ratio, we can infer that the square root of 234 minus the square root of 225 should be 9 divided by 31, which is essentially 9/31. Therefore, we can now estimate the square root of 234 is 15 and 9/31. Now, put that into a calculator. It's around 15.266. The real value of the square root of 234? 15.297. Very close, right? Yes, very close. And in fact, there's a reason why we can only say very close, as opposed to precisely correct. Because unlike plus minus, an exponential or inconsistent numerical growth cannot be calculated by splitting the quote-unquote distance into sections of equal length, as we did with the original numbers without the roots. Okay, that is it for today. Hopefully this lesson has helped you better understand how to estimate square roots, and also why you can't really calculate the exact value of a square root. Please like and subscribe, and see you next time.